In this video, I want to demonstrate the Azure Percept Vision camera with a real-time fish monitoring station. I'm going to use the Percept Vision camera for four main purposes. One, to capture the images through Percept to label and train the model, deploy the model in Percept, capture the message from the IoT device and stream it to a database, and finally generate reports. I have given a high-level agenda that I'm going to cover in this exercise. Let's have an overview on the Percept SDK. Microsoft Azure portal contains the details of the Percept device. There are several features and detailed information and configuration about the Percept device are provided. We can take a look. In this specific exercise, we are interested in looking at the vision camera that has been pointed here. So I'm going to go through a demo using this. This is a sample video taken from the fish tank. We wanted to count the number of fish within the tank at a given point in time, and also the average fish count for a given hour, and also how active the fish is. As a first step, we have placed the camera in front of the fish tank to capture the images of the fish tank along with the fish in order to tag and train the model in the custom vision. The Azure Percept reference architecture categorized into three major parts: on-premises, Azure Cloud Platform, visualization. On-premises, we install the Percept device and connect the Percept to the Azure Cloud through IoT Hub. There are three flows presented in the architecture: image capture, model deployment, video streaming. The Percept iVision captures the images and it stores in the cognitive services. This has been shown in the flow 1. Um, and Once the images are tagged and trained, the model is deployed through flow 2 into the Percept device. After the deployment, we invoke the video streaming where we could see the prediction happening. The flow 3 contains the telemetry data, and the data is streamed through the data stream analytics and stored in SQL database. Finally, the Power BI reports are generated using the stored data, and it will help the biologist to take appropriate action. In cognitive services, we create a project under custom mission to store our images to label and train the model. So once we created the project, in this case, I have already created a project. So what I'm going to do is, like, now I need to capture the images. So you have to select your project to capture the image. So my project is this one, and we have two options. Either you can take a single photo or you can do an automatic capture. So in my case, I want to take many pictures of the fish. So and posture of the fish. So I took around 500. So I already did, and then I have taken a picture. I just wanted to show. So once this is completed, your images will be stored automatically in the project where you could see the images. Here you have to basically tag the images to train our model. So I already been tagged some of the images. So this is for an example I am showing. So once the image has been tagged, so you can train your model. So basically we have a quick train or advanced train. I have did the three sets of iteration, and one is an advanced one. That is the one I am going to use it for our model. So this one is the result of my model performance, this metrics. So I'm quite happy with the metrics. So once the model is ready, I go to deployment in the Azure Percept device, where we have an option to deploy the project. It is a no code deployment, where again I have to select the cognitive services project, and then I have to select the iteration that has been I have done. So in this case, I have taken the advanced one, so that it will make more prediction. So I deploy this model. Once the model has been deployed, you will see something is going on like this. Some fishes has been randomly, you could see here, right? So this is how it predict the fish. At the same time, you also have to check how the data being captured. So you could see there are some telemetry messages being posted on the IoT edge devices. So where I could see a lot of messages pertain to the prediction. So these are some, I could see the labels are fish and confidence level. And this specific exercise, I am only interested on the count. So this specific model has been already provided by Microsoft. I'm leveraging that for my purpose. So I'm happy with the telemetry messages being received. Once we confirm the telemetry messages in the count model, two other things we have to do. One is the streaming analytics job, the other one the database. So in the streaming analytics job, we have to basically identify whether whatever the telemetry message has been pushed or streamed through the system. From this, I can confirm that the data has been streaming through the IoT hub, and we can use this data to store into a database. So the input for the the input is been defined in the streaming job, and the output we have defined in a database. So what basically what we are doing here is like we are streaming the telemetry messages into a IoT and then storing into a database. So as you could see, this is another process we need to set up to get the event data and then store it in a database. So this confirms that my data has been pushed into a database through streaming analytics job. Now I am going to check in the database. In the database, I have created a table, and where I am storing that streaming data in a desired format where I can generate a report later point in time. At this point, I could see the data has been pushed. So I could see the data has been updated. So what I'm going to do is like next, we are going to generate a report based on this. This is the final section of this exercise, the report dashboard. Dashboard is created through Power BI Desktop. The first time series graph on top shows the fish count. The model deployed in the Percept identifies number of fishes in monitoring area at minute level in real time. Also, the bottom level shows average count of fish in a given hour is displayed. In this example, it is 5. Finally, an interesting report bottom right is generated to find the fish activeness in a given day, whether the fish is very active on the morning or night or in the evening. From the report, the fish are more active in the evening. The Percept camera is placed in front of the fish tank. Now the data is been live streamed to the cloud platforms where the model can visualized. So the count model has been deployed in the Percept device, and now the model is predicting the fishes within the vicinity, and I could see the fishes are being identified in the tank.